In this video, we will discuss lines and angles. A point is a location or position that has no size or dimension. A dot is used to represent a point, and a capital letter may be used to label the point. A line extends indefinitely in both directions and contains an infinite number of points. It has length but no width. In our discussions, the word line always references a straight line. When I talk about something that is curved, I will use the word curve. A line can be identified by naming any 2 points on the line. A plane is a flat, smooth surface that extends indefinitely in all directions. A plane contains an infinite number of points and lines. Since a line extends indefinitely in both directions, most geometric applications deal with parts of lines. A part of a line is called a line segment or just a segment. A line segment starts and stops at distinct points that we call endpoints. A line segment consists of all points on the line between and including the 2 endpoints. The notation for a line that extends through points A and B is a double-headed arrow over AB, red line AB. The notation for the line segment, including the points A and B and all the points between A and B, is a straight line over AB, red line segment AB. A ray consists of a point on a line and all points on the line on one side of the point. The point from which the ray originates is called the endpoint, and all other points on the ray are called the interior points of the ray. A ray is named by its endpoint and any interior point of the ray. We use the notation single right pointing arrow over AB to denote the ray whose endpoint is A and that passes through B. A line extends infinitely in both directions. If 2 lines are drawn in the same plane, one of these situations will occur. The 2 lines intersect in one and only one point. The 2 lines coincide, that is, one line fits exactly on the other, and they contain all the same points. Or third, the 2 lines never intersect. They are the same distance from each other, their entire lengths, and never touch. Such lines are called parallel lines, and we use the symbol 2 straight lines side by side to designate this property. Use this figure to answer the following. Name a ray with an endpoint of Q and passing through P. Either ray QM or ray QP will work as a name for this ray. Do line LM and line MN represent the same line? Yes, they do, since LM and N are all on the same line. Do line segment PQ and line segment QP represent the same line segment? Yes, they have the endpoints are in a different order, but they have the same endpoints. Name 2 lines that are parallel. Line RS is parallel to line PQ. We can also say that's line QM or line MP. There are a number of different ways to write those lines. When 2 lines intersect at a point, 4 angles are formed. An angle is a geometric figure formed by 2 rays that intersect at a point, and the point of intersection is the endpoint of each ray. In the line below, rays AB and AC intersect at point A. Point A is the endpoint of AB and AC. Ray AB and ray AC are called the sides or legs of the angle. Point A is called the vertex of the angle. Angles can be named either by using the name of the vertex with the angle symbol or by using the name of a point on each leg of the angle with the name of the vertex between them and, again, the angle symbol. The angle depicted in the figure below could be called angle A, angle BAC, or angle CAB. The figure below shows that 2 rays originating at a point actually form 2 angles. Generally, we will refer to the smaller of the 2 angles formed by the rays unless the other angle is specifically indicated. Arcs, sections of circles, and arrows are often used to clarify which angle we are considering. Use the figure to answer the following. Name the angle with 1 capital letter. that is angle X. Name the angle with 3 capital letters. We could call this line YXZ or angle ZXY. Either one is just fine. And we can name the angle with a number. It would be angle 1, since there is that 1 inside the angle. Classify angles according to size. The measure of an angle is determined by the amount of opening between the 2 sides of the angle. The length of the sides does not affect the angle measure. 2 units are commonly used to measure angles, degrees and radians. In this lesson, only degrees are used to measure angles. Radians are discussed in 17-3. If the 2 rays forming the angle point to the same point, the angle has a measure of 0 degrees. There are a total of 360 degrees in a full circle. If we rotate one ray all the way around so it points back at the same point as the other ray again, it has traveled 360 degrees and yet still looks like the same 0 degree angle. Effectively, 0 degrees is the same as 360 degrees when we look at angles. The customary rotation around a point progresses opposite to the normal rotation of the hands of the clock. The direction is called counterclockwise. Clockwise is the circular rotation in the same direction as the normal rotation of the hands of a clock. This corresponds to the negative rotation of an angle. A degree is a unit for measuring angles. It represents 1/360th of a complete rotation about the vertex. An angle that is 1/4 of a complete rotation, or 90 degrees, is called a right angle. If 2 lines intersect so that right angles are formed, the lines are perpendicular to each other. The symbol for perpendicular is this upside down T shape. If a string is suspended at one end and weighted at the other, the line it forms is a vertical line. A line that is perpendicular to the vertical line is a horizontal line. In the figure above, line AC is a vertical line and line AB is a horizontal line. So line AB is perpendicular to line AC. An angle that is half of a full rotation, 180 degrees, is called a straight angle. An angle that is less than 90 degrees but more than 0 degrees is an acute angle. An angle that is more than 90 degrees but less than 180 degrees is an obtuse angle. To classify angles according to size, first examine the angle to determine the number of degrees it measures, approximately. Then classify the angle as right, straight, acute, or obtuse based on the degree measure. Classify these angles according to size. Angle 1 is acute, angle 3 is acute, angle 2 is obtuse, angle 4 is obtuse. Angles 5, 6, 7, and 8 are all right angles, and angle 9 is a straight angle. If 2 angles together form a right angle, or if their measures total 90 degrees, they are complementary angles. If 2 angles together form a straight angle or their measures total 180 degrees, they are supplementary angles. To find the complement or supplement of an angle, subtract its measure from 90 degrees. To find the supplement of an angle, subtract its measure from 180 degrees. Find the complement and supplement of an angle that measures 57 degrees. The complement of 57 degrees is 90 minus 57, which is 33 degrees. The supplement, 180 degrees minus 57 degrees is 123 degrees. So the supplement of 57 degrees is 123 degrees. When the word equal is used to describe the relationship between 2 angles, it implies the measures of the angle are equal. Another word often used in geometry is congruent. When geometric figures are congruent, one figure can be placed on top of the other and the 2 figures will match perfectly. If 2 angles are congruent, the measures of the angles are equal. Also, if the measures of 2 angles are equal, the angles are congruent. The symbol for congruence is an equal sign with a wavy line over it. The angles in the figure below are congruent. We indicate the measures of angles by placing the letter M before the angle symbol. So M angle BAC equals M angle FED tells us that the measure of angles BAC and FAD are equal. Intersecting lines generate several angle relationships. When two lines intersect, two pairs of vertical angles are formed. Two angles that share a common side are called adjacent angles. In the figure below, angles 1 and 3 are vertical, as are angles 2 and 4. Angle 1 is adjacent to angles 2 and 3, and both angles 2 and 3 are adjacent to angle 4. A transversal is a line that intersects two or more lines in different points. When a transversal intersects two lines, 8 angles are formed. In the figure below, the angles inside the lines 3, 4, 5, and 6 are called interior angles, and the angles outside the lines 1, 2, 7, and 8 are called exterior angles. An exterior angle and an interior angle on the same side of the transversal and in the same relative position on the intersecting lines, such as angles 1 and 5, are corresponding angles. Alternate angles are on opposite sides of the transversal. Angles 1 and 8 are alternate exterior angles, and angles 3 and 6 are alternate interior angles. When parallel lines are cut by a transversal, we can determine a great deal about the measures of the angles involved. Corresponding angles are equal, adjacent angles are supplementary. Interior angles on the same side of the transversal are supplementary, and exterior angles on the same side of the transversal are supplementary. In the figure below, the lines cut by the transversal are parallel, and the measure of angle 2 is 125 degrees. Find the measures of the other angles. Angles 1 and 2 are adjacent, so they are supplementary. Therefore, the measure of angle 1 is equal to 180 minus 125 degrees, which is 55 degrees. Likewise, angles 2 and 3 are vertical angles, so they are equal. The measure of angle 3 is 125 degrees. Likewise, angles 1 and 4 are vertical angles, so they are equal, and the measure of angle 4 is 55 degrees. Angle 5 corresponds to angle 1, so they are equal, and angle 6 corresponds to angle 2, so they are equal. Likewise, angle 7 corresponds to angle 3, and angle 8 corresponds to angle 4. From this, we can tell that the measure of angle 5 is 55 degrees, the measure of angle 6 is 125 degrees, the measure of angle 7 is 125 degrees, and the measure of angle 8 is 55 degrees.